Hello students, welcome on YouTube channel Chemistry by Shivam Education। डियर स्टूडेंट्स, अभी हमारा अल्कोहल फिनोल ईथर चैप्टर कंटिन्यू है और हमने ऑर्गेनिक केमिस्ट्री स्टार्ट करके ऑलरेडी 2 चैप्टर अपलोड कर दिए हैं। नाइट्रोजन कंटेनिंग ऑर्गेनिक कंपाउंड एमाइंस पूरा अपलोड हो चुका है और अल्डिहाइड कीटोन कार्बोक्सिलिक एसिड ऑलमोस्ट कंप्लीट हो गया है। तो यदि आपको इस चैप्टर की पढ़ाई बाकी है तो आप चैनल के प्लेलिस्ट में जाइए और 1 बाय 1 वीडियो लेक्चर के माध्यम से आप उन चैप्टर की भी पढ़ाई कर सकते हो इस चैप्टर के साथ। यदि आप इस चैनल में पहली बार है तो जल्दी से सब्सक्राइब कर लीजिए और बेल आइकन को टच कीजिए, जिससे आपको आने वाली हर वीडियो लेक्चर की जानकारी मिलती रहे और आप अच्छी तरह से पढ़ाई कर पाए, कोई भी लेक्चर मिस न हो। डियर स्टूडेंट्स, ये चैनल हम आपके लिए ही चला रहे हैं। इस चैनल के उन बच्चों के लिए है जो कोचिंग में नहीं जा रहे या कोचिंग एफोर्ड नहीं कर पा रहे लेकिन वो पढ़ना चाहते हैं। तो एनसीईआरटी के हर चैप्टर के हर टॉपिक की कॉन्सेप्ट वाइज अंडरस्टैंडिंग आपको इस चैनल के माध्यम से मिलेगी। तो आपको वीडियो लेक्चर देखना है, पढ़ना है और उसके साथ साथ अपनी नोट भी बनानी है और लगन से और जी जान से ये काम करना है, जिससे आप आपके और आपके पेरेंट्स के सपने पूरे कर सको और जीनीट में अच्छा स्कोर प्राप्त कर सको। तो चलो स्टार्ट करते हैं नेक्स्ट लेक्चर। हेलो स्टूडेंट्स, इन टुडे लेक्चर वी विल डिस्कस Fry's rearrangement reaction. Now the principle of Fry's rearrangement reactions: ester of phenol, when heated in the presence of Lewis acid like a anhydrous AlCl3, then it gives us phenolic ketone, and this rearrangement reaction is known as a Fry's rearrangement reactions. So whenever ester of phenol heated in the presence of Lewis acid, we get hydroxy ketone or phenolic ketone will be obtained, and this is Fry's rearrangement reaction. So first, how ester can be obtained from phenol? First, just I am giving you simple reactions. पहले हम ऐसे ही reaction पढ़ेंगे. Now we have this structure which is known as a phenol. Now phenol, when allowed to react with aqueous solutions of sodium hydroxide, then we get a sodium phenoxide. Reaction occur in this way: Na plus, OH minus, here H plus and oxygen minus. So OH react with H, remove in the form of H2O, and we get a sodium phenoxide. So first sodium phenoxide will be obtained, Na plus, O minus. Now whatever sodium phenoxide obtained to us, it allowed to react with a acetyl chloride. When it allowed to react with acetyl chloride, reaction occur in this way: Na plus combined with Cl, remove in the form of NaCl, and we get phenyl acetate. This phenyl acetate is nothing but an ester of phenol. So it is known as a phenyl acetate, or which is nothing but an ester of phenol. Now this ester of phenol, when heated in the presence of anhydrous AlCl3, just we heat this thing in the presence of anhydrous AlCl3, then hydroxyl group is ortho para directing group, so this aceto group will either go in ortho position or in a para position. So as a result we get mixture of this type of product. This will be ortho hydroxy acetophenol, and next structure is para hydroxy acetophenol. So we get the mixture of ortho or para hydroxy acetophenol. Name of this structure, just we can write that ortho or para hydroxy acetophenol. So now which product will be obtained, ortho or para? Then it depending upon concentration of catalyst and temperature. At a low temperature, ortho will be obtained as a major product, and at a high temperature para will be obtained as a major product. So now how this chemical reaction occur, how this rearrangement reaction occur, this we will understood with help of mechanism. Now we have this structure phenyl acetate. Now in phenyl acetate, oxygen having a non-bonding electron pair and aceto group. So we have taken anhydrous AlCl3 as a catalyst. So when heated in the presence of catalyst, then this oxygen give it non-bonding electron pair to this aluminium. So when this oxygen give non-bonding electron pair to this aluminium, we get this type of structure. Now oxygen have given electron pair to aluminium. So this oxygen having a positive charge, here AlCl3 have get a negative charge. Now oxygen having only one non-bonding electron pair, and here we have a aceto group COCH3. In order to obtain stability, in order to obtain electron pair back, ये ऑक्सीजन इलेक्ट्रॉन खींच लेगा कार्बन ऑक्सीजन बॉन्ड का. सो वी गेट दिस टाइप ऑफ स्ट्रक्चर. नाउ हियर ऑक्सीजन आएंगे once again two non-bonding electron pair and here AlCl3, but this AlCl3 aluminium having a negative charge, and with this we are getting CH3CO plus. This whatever CH3CO plus obtained, it is known as a acyl cation. This we can write in this way also. Here CH3 C triple bond O, and here carbon having a positive charge. So this is nothing but as acylium cation. So this acylium cation is obtained to us. Now whatever structure obtained to us, here this structure bond we can write in this way. Double, single, double. In this way we can write this bond structure. Now here aluminum having a negative charge, the stability of structure is less. So in order to obtain stability, this bond electron will be taken back by oxygen, and this pi bond donate electron pair to this carbon of acyl cation. So when it give electron pair, this pi bond give electron pair to carbon, this bond will break. At the same time, this oxygen aluminium bond electron pair will be taken by oxygen, and double bond form between this structure. So we get this type of structure. Now here double bond with oxygen. Now oxygen will get two non-bonding electron pair and double bond. Now here carbon joined with this as a COCH3, and here hydrogen carbon. This carbon of phenyl ring having a hydrogen, so it is written as it is. Now here in this structure, when bond formation occur, this pi bond break in electron pair given to this carbon, aromatic structure means aromatic property is broken. So in order to regain aromatic character, once again this rearrangement reaction occur. Now hydrogen bond electron pair given to this, hydrogen bond electron pair is given to this carbon. So this carbon double bond form. At the same time this pi bond break and electron pair transfer on this oxygen, and ultimately oxygen give electron pair to this hydrogen. So we get this type of structure here. Now this double bond as it is, this bond break, electron pair obtained by carbon, and carbon have given to this carbon. So carbon double bond formation. Now COCH3 as it is, this pi bond break, electron pair goes to oxygen, and oxygen are given electron pair to hydrogen, and this structure is nothing but orthohydroxyacetophenol. Suppose attack occur by a para positions, or attack occur on para position, then we get para structure. Once again I will write this structure as it is: double bond, here double bond, and here oxygen having a non-bonding electron pair, negative charge on aluminium, AlCl3, so negative charge on aluminium. Now assume that suppose this pi bond electron is given to this acyl cation, then here double bond formation occurs, so we get this type of structure. Here double bond broken, double bond form between this carbon and oxygen, so we can write oxygen double bond, then ultimately this pi bond break, and here double bond, and we get this type of structure COCH, here hydrogen atom. Once again rearrangement reaction occurs, this hydrogen electron pair bond formation occur, this bond break, electron pair transfer at here, this bond break transfer at here, electron pair, and on rearrangement reaction, suppose attack occur on para position, then we get once again this type of para structure. So whenever ortho or para hydroxyphenol ester when heated in the presence of anhydrous AlCl3, then we get ortho or para hydroxy acid of phenol. This reaction is known as a Fraser rearrangement reactions. Here oxygen and a non-bonding electron pair, it is given to aluminium. This is a Lewis acid. So it take or accept electron pair. Oxygen get negative positive charge and aluminium get a negative charge. Now once again, in order to obtain stability, here carbon oxygen bond is broken, electron pair transfer on oxygen, and as a result we get acylium cation, and with this we have oxygen aluminium with a negative charge. Now this pi bond electron pair attack on this carbon cation of acylium cation. It give electron pair to this, so a bond formation occur between this carbon and carbon. Now this carbon and hydrogen, to obtain aromatic character back, this bond is once again formed between carbon and carbon, double bond form. This pi bond break, electron transfer on oxygen, oxygen give electron pair to hydrogen. So oxygen give electron pair to hydrogen, so oxygen hydrogen bond form. Here double bond form between carbon and carbon, and as a result we get a ortho hydroxy acid of phenol. Similarly, suppose attack occur with a para position, then we get a para hydroxy acid of phenol. So this is Fraser rearrangement reaction. By using this, one can prepare different type of ketone. और यस, यदि आप इस चैनल पर वीडियो लेक्चर स्टडी कर रहे हैं और आपको एडवांटेज मिला, फायदा मिला, तो फिर उन बच्चों तक भी ये वीडियो चैनल की लिंक भेजिए, इस चैनल की लिंक भेजिए, जिससे वो भी आपकी तरह एडवांटेज प्राप्त कर सके।